This model of blast machine is a little bit different than the impacts in that the rebound plenum, that's this piece right here, is more at a 90-degree angle to the floor. So the blast housing, where the shot is introduced into the wheel and then thrown at the floor and then bounces back up, if that angle was complementary on the return, or let's say the rebound, it would be more like this. Because when it hits the floor, it hits and then it has to some extent, bounce up and then hit this wall. That will slow the speed of the shot and the dust that comes up. Dust collection takes place here, which is angled, which is a big help because the idea is to keep that air flowing so that the dust is more adequately pulled out than maybe in older models where the port would have came straight up. The relation though can't be avoided between this angle and the amount of shot that can go to the floor. I cannot put more shot to the floor than I'm able to recover. If this area doesn't move the shot out of the way fast enough, then the shot that's entering here is going to, of course, start to hit the material that's supposed to be leaving the area. And when those two collide or start to run into one another, the amount of material that's in suspension as gravity takes hold, the dust in the shot then falls to the ground. The impacts has a curved rebound plenum. Because of the curved rebound plenum, the shot as it's thrown at the floor is able to more naturally, as it hits and wants to bounce. The idea is that this angle that the shot is thrown at the floor and then this angle are complementary to the extent that as the shot hits, it more naturally wants to bounce up and not run into the wall of the rebound plenum. When it gets up to the top of the circuit, the idea is that as the shot comes up and then the air is tumbling in here to clean the shot, the dust that's attached to it will come up to the return and then leave to the vacuum.